Hello everyone, my name is Arnav Agrawal and today we will be going through coordinate geometry. I am currently in my second year of electrical engineering at IIT Bombay. Let's start today's session. So let's go through some basics of coordinate geometry, conic sections. So we all know that we studied straight lines last session. Let's continue with circle, ellipse, parabola and hyperbola. Yeah, so let's continue on. One second. So we all know what a circle is, right? It's basically a set of all points in a plane that are equidistant from a fixed point in the plane, right? That fixed point is the center, and so basic definitions we all know, right? And so to get the locus of the circle, or we can say to get general equation of the circle, what we need to do is we can say that this distance CP is the radius R, right? And this is for all the points P on the circle. This is true, right? It's basically using the definition of the circle, that all the points in the plane are equidistant from the all the points on the circle are equidistant from the center, right? So जो एक सेकंड सारी डिस्टेंसेस उसको हम आर से इक्वेट कर सकते हैं. Yeah, so we can equate all the distances to r. So what we can say is by the distance formula, root of x minus x whole square plus y minus k whole square is equal to r, right? And taking square on both the sides, we will get x minus x whole square plus y minus k whole square is equal to r square. So this is an equation for a circle with center h comma k and radius r. This is the general equation which you can use anywhere, given the this center and radius. So for example, let's say this, find the equation of the circle with center minus 3 comma 2 and radius 4. So by just putting in the values, we can get the equation. It's simple, right? Now look at this example. Find the center and radius of the circle. So this equation is given. See, if you expand this equation, this highlighted one, you will get something like this. Not exactly this, you will get in terms of HKR, but something, the form would be like this, right? So what we will do is we will try to bring this thing into in form of this general expression so that we can find H, K, and R easily. So again, clubbing the terms, x square plus 8x plus y square plus 10y and getting the constants on the right hand side, we can use completing the square method. By that, we will get x plus 4 whole square plus y minus y plus 5 whole square is equal to 49. We can then easily get the center and the radius by comparing to this general expression for the circle with center h comma k and radius r, right? So this was some basic point about circle. You can go through this one also. It's just application. Let's move forward, or let's go to that example. It's important. So find the equation of the circle which passes through the points 2 comma minus 2 and 3 comma 4 and whose center lies on the line x plus y equal to 2. So we can use this general expression. We can plug these 2 points, 2 comma minus 2 and 3 comma 4 into this general expression so that we can get two equations. Why can we put these 2 points? Because these 2 points satisfy the equation of the circle since they are lying on the circle, right? So we get these two equations. And since the center lies on the line x plus y equal to 2, we can plug in h comma k in this line equation, right? Because h comma k is the center of the circle and that center lies on this line. So h comma k equal to 2. When we will solve these three equations for three unknown variables, which is h, k, r, we will get all the three variables. And once we get them, we can plug them back into the general expression to get the final equation of circle, right? So this was also simple, but little bit twisted. You will get to see these kind of questions a lot everywhere, actually. Okay, let's move forward. Let's continue with parabola now. A parabola is a set of all points in a plane that are equidistant from a fixed line and a fixed point, which is not on the line in the plane. So what in the case of a circle, in the case of the circle, what we learned was the all the points of the circle were equidistant from the center. On the parabola, all the points are equidistant from the line and the point, which is not on the line. So this line is called the directrix of the parabola, and this point F is called the focus. Okay. So these are the terms which you need to remember, and you must have played with these terms a lot, right, while solving the questions. So a line through the focus and perpendicular to directrix. A line passing through the focus and perpendicular to directrix is called the axis of the parabola. This also needs to be remembered. Okay. And the point of intersection of axis of parabola with the parabola, which is this point, is called the vertex. Okay. So these four terminology you have to like get in your mind. Let's continue with standard equations of parabola. Okay. So let's first start with the simplest of them. Okay. There are quite a lot of types of parabola. Let's start with the simplest, where axis is the x-axis. Axis of the parabola is nothing but the x-axis of xy plane. And yeah, and vertex is at the origin. Okay. So with these two things, there can be two types of parabola, right? As you can see here. Similarly, we can take okay, there can be four types, my bad. So sorry. There can be these four types, okay? So with okay, so wait, one second. With the axis of the parabola as x-axis, we can have two parabolas. With the axis of the parabola having y-axis, we can have another two parabolas, okay? These are basically nothing but the standard parabolas, okay? The basic parabolas. Now, just like the way how we derive the standard equation of a circle in terms of center and radius, we can do it here as well using just the definition, like we used in the case of circle. So we have to equate the distance of a random point on the parabola from focus and the directrix. Assuming focus is a comma 0 because it lies on the x-axis, because axis lies on the x-axis, and taking this point B on directrix as minus a comma y, and taking random point P as x comma y. We can equate these two distances, right? After equating these two distances, what we get is y square equal to 4ax. where a is greater than 0. Okay. So take time to absorb this. Y square equal to 4ax. This thing is the least which you should know in the parabola chapter. Okay. Because most of the questions, at least in JEE mains, is based on only this parabola. Basically, they can change the center, of course. They can play with different properties of this parabola, but it is uh, basically based on this. Okay. And so basically, this equation of this parabola, specifically this one, a part, is nothing but y square equal to 4ax, where a is greater than 0. Okay. So we are taking a greater than 0 in all of them. Fine. Here we change the orientation to opposite of part A. So here y square equal to minus 4ax. Here we interchange x and y. We get x square equal to 4ay, and here x square equal to minus 4ay. So I hope it is clear. And in this case, the directrix is x equal to minus a. If I remember well, this point is called the foot of directrix, if I'm not wrong. So this point, let me annotate it. 1 second. Yeah, this point. So this point, let's say it is B. You have to remember, always remember that BO is equal to OF, okay, in all parabolas. This point to this point distance is equal to this point to this point distance. So if this point is origin, this is a comma 0, then this point is minus a comma 0. And since this line has to be perpendicular to x-axis, because axis of the parabola is nothing but the x-axis, so this directrix is nothing but x equal to minus a, right? Now let's move on to another very important property, or something related to parabola, that is lattice rectum. So lattice rectum of a parabola is a line segment perpendicular to the axis of the parabola through the focus and whose endpoints lie on the parabola. This line is nothing but the lattice rectum. Now let's find the length of this lattice rectum. So it's perpendicular to the focus and it passes through the focus, right? So let's try to find the length. By this diagram, you can see that AF is equal to AC. I mean, not by this diagram, but yeah, you already know that AF equal to AC by the definition of the parabola, right? And by this, as you can see, this rectangle or square, whatever you want to say, you can say that AC is equal to FM, right? AC equal to FM, and FM, you know, it's A plus A, which is 2A, because MO is equal to OF, and OF is A, right? So this is 2A, so AC is 2A, and since AC is equal to A, 2A, and since AF is equal to FP by 73, AB is nothing but 4A, right? AB is nothing but 4A. You have to remember this, right? Please remember that lattice system of this standard parabola is nothing but 4 times A. So let's find the coordinates of the focus axis and equation of the directrix. Find the coordinates of the focus axis, the equation of the directrix, and latter spectrum of the parabola. Coordinates of the focus axis and equation of the directrix and latter spectrum. Okay. Yeah. So let's see. This y square equal to 8x is nothing but a standard parabola only, where a is equal to 2. When we compare this with equation y square equal to 4x, we get a is equal to 2, right? And when we get a is equal to 2, we can directly say the focus is first of all 2, 0. Axis is 0, 0 because this is a standard parabola. Equation of directrix would be x equal to -2 because we know it is x equal to -a, right? And lattice vector, so whenever someone says what is the lattice vector, he means the length of the lattice vector. Okay, most probably. I've seen in many questions before. Unless the options are in terms of equation, then it's a different point. Okay. So length of the lattice vector is nothing but 4a, which is 4 into 2, 8. This it was a simple question, just an application of the formula. Let's move further. Find the equation of the parabola with focus 2, 0 and directrix x equal to -2. Again, it's the same thing. It's just confirming, or you can say, since focus is 2, 0 and directrix is x equal to -2, we can say the axis of the parabola is nothing but the x-axis. Because focus first of all lies on the x-axis and it is perpendicular to that, right? So again, it would be either y square equal to 4x or -4x. Since directrix is -2, x equal to -2, then hence it is y square equal to 4x form, right? And a is equal to 2, so we get y square equal to 8x. Fine. Let's are just application of this formula. This was parabola. Now let's move on with ellipse. Yeah, so an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in the plane is a constant. So all these points on the ellipse, whichever points lie on the ellipse, all these points are equidistant from these two focuses. Sorry, my bad. The sum of the distances from both the focuses is a constant. Okay. And this distance, this sum of the distances is always greater than the distance between these two focus. Okay. So F1, F2 is less than the sum of the distances. That's what is written in this blue box. And this is actually important to understand. Okay. So the midpoint of the line segment which joins these two focus, F1, F2, that is nothing but the center, okay, of the ellipse. And the line joining these two foci is nothing but the major axis. And the line perpendicular to this major axis, but passing through the center, is nothing but the minor axis, as shown in the diagram. These endpoints are called vertex, A and B. The major axis, wherever it cuts the ellipse, those 2 points are called vertex. Okay, so there are some standard lengths which are associated with these axes, sorry. So this 0b, here 0b, right? Half of the major axis. That is nothing but A. So we take the length of the major axis as 2a, the minor axis as 2b. Okay. This 2c is not significant. We don't need to remember that, but this 2a and 2b are important. Okay. I suggest that do not take this whole length as A unless defined, and this whole length as B unless defined, right? Go by the convention. Eccentricity. So now let's define eccentricity. The eccentricity of an ellipse is the ratio of the distances from the center of the ellipse to one of the foci and to one of the vertices of the ellipse. That is C by A. Standard equations of an ellipse. Okay. The equation of an ellipse is simplest if the center of the ellipse is at the origin. Okay, so let's move forward. So these two ellipses are standard ellipses where the major axis is x-axis, minor axis is y-axis, or vice versa. Similar to the way how we derived the parabola and surface standard equation, here also we can do the same. Okay. Also one thing, the sum of the distance of any point from the foci is nothing but 2a. Okay. Please remember this. And that 2a is nothing but the major axis line. So when we write the expression by using the distance formula and solving it will give us this equation: x square upon a square plus y square upon b square is equal to 1. This equation has to be remembered by heart. In any case, you should not forget this. And in case of the second standard ellipse, it's just the reverse. Here it's x square upon b square plus y square upon a square is equal to 1. Okay. And we can infer from the standard equations of the ellipse that ellipse is symmetric with respect to both the coordinate axes. Because if xy lies on ellipse, then minus x comma y, x comma minus y, minus x comma minus y also lies. Okay. These points you can also infer by your own. These are very, very basic points, which you can infer from the diagram itself, right? You can clearly see this is symmetric with x-axis and y-axis both. Okay, so latus rectum. So latus rectum here also it's present. We saw in the parabola case first. Latus rectum of an ellipse is a line segment perpendicular to the major axis through any of the foci whose endpoints lie on the ellipse. Okay. Well, if you solve this equation, if you even do not, just remember that length of the lattice rectum is nothing but 2b square upon a. Please remember this because this is very, very important. This is hell important. Okay. So length of the lattice rectum is 2b square upon a. Now again you can find all those stuff. by using the equation. Let's now study the hyperbola. Hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points in the plane is the constant. So earlier it was sum, here it is difference. Okay. Earlier it was sum, now it is difference. So while finding the general equation, we will just change the sum by the difference, and we can get standard equation as x square upon a square minus y square upon b square equal to 1. Okay. Here also eccentricity c by a. Eccentricity of ellipse is always less than 1, and hyperbola is always greater than 1. If eccentricity is 1, then it's a circle. Remember this. Okay. Eccentricity is 1 for circle, less than 1 for ellipse, and greater than 1 for hyperbola. Again, standard equation, these two standard hyperbolas are there. I just now told that standard form equation of hyperbola can be gotten by x square upon a square minus y square upon b square equal to 1. And in case where we change the axis, then it's y square upon a square minus x square upon b square equal to 1. Okay. Yeah. So hmm, again note that in the case of ellipse, the sum of the distances was getting equated to 2a. Here, the difference of the distances from the two foci of any point on the hyperbola is nothing but 2a also. Okay, so we can get the equations by the same method. A hyperbola in which a is equal to b is called an equilateral hyperbola. This terminology you don't need to remember. I don't think so, but you can keep in the back of your mind. That is hyperbola. If a is equal to b, then it's an equilateral. Okay. Hmm. Okay, so there is something called transverse and conjugate axis of the hyperbola. Okay, so the line through the foci is called the transverse axis, and line through the center and perpendicular to transverse axis is called the conjugate axis. They are just analogs of major and minor axis of the ellipse. Okay, so this distance where the hyperbola cuts the conjugate axis. No, my bad. So sorry, it doesn't cut. So sorry. So so basically this AB distance is nothing but what? It's 2A. Okay, so also note, yeah, this is very crucial. The foci is the foci are always on the transverse axis. Please remember, it is the positive term whose denominator is the transverse axis. This is really very important. Here, definitely the main paper can trick you, and you will get puzzled. You will remember that the foci, the distance a is nothing but the denominator of the x square term. That's not true. Here, in this one, where the transverse axis is nothing but the x-axis, the transverse axis along x-axis is of length 6. Why 6? Because this is the length of the transverse axis is 2a and a is 3, because this is the positive term, x squared by 9. But if we reverse this, if we say this is the equation of the parabola, then transverse axis would be 10 along y-axis. Because first of all, the transverse axis is the y-axis, right? Is along y-axis, and it's the length is 2a, a is 5 here because this is the positive term. Okay, yeah. Again, let us rectum. Here also the formula remains same. 2b squared upon a. Okay, 2b squared upon. These questions can be done easily. So let's now see some miscellaneous questions. The focus of the parabolic mirror, as shown in figure 10.31, is at a distance of 5 centimeter from the vertex. That means A is nothing but 5. If the mirror is 45 centimeter deep, find the distance AB. So this distance is nothing but 45. And this AB is what we need to find. We all know that y square equal to 4x is the equation, right? And it's since it is y square equal to 4ax, right? So if it's y square equal to 4ax and x we know is 45, why? Because 45 is the distance from origin and that's what the x coordinate as well. If you put x equal to 45 in this, you will get y is equal to plus minus 30. And so 2y is nothing but AB, which is 60 centimeters. 30 minus of minus 30, right? It was simple. A beam is supported at its ends by supports which are 12 meters apart. Since the load is concentrated at the center, there is a deflection of 3 centimeters at the center, and the deflected beam is in the shape of a point. I guess these type of questions you should try on your own. These are pretty straightforward questions. I don't think this like we should give much time to this for JEE-Main. Okay, let me show you some other thing. Yeah. Let me go through go through some points which are extremely important. Okay, so let's see tangent of a circle at a given point. So we define something called t. Okay, t equal to 0. This is nothing but the equation of a tangent at a point P, x1, y1 to the circle. Okay, this P lies on the circle. This is the standard equation of a circle. So I just told you that if the center of the circle is h comma k and radius is r, then we know its equation is x minus h whole square plus y minus k whole square is equal to r square, right? But this is also another equation, and this is actually more standard equation of a circle. X square plus y square plus 2gx plus 2fy plus c equal to 0. This is general equation of a circle, and correspondingly x1 plus y1 x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0 is nothing but t. Okay, so this is the equation of tangent of a circle. This you have to remember this by anyhow. Okay, this is very, very important. Another form. So this was point form, where a point is given and you need to find the tangent. Now we see parametric form. So we take x and y as some parameters, which is, let's say, r cos theta, and not x and y, but yeah. So x is equal to r cos theta, y equal to r sin theta. Okay. So yeah, when we take this and we plug it into this equation, then we open this. What you will get is this alpha beta would be something like look something like this. Alpha is nothing but x1 plus r cos theta. Beta is nothing but y1 plus r sin theta. Okay. Slope form again we can get in terms of slope form y equal to mx plus c. So there is a general line y equal to mx plus c. We need to make it a tangent to the circle. So for that, so that condition would be what? A equal to mod c by root 1 plus m square. Why? Because this distance from the center of the circle should be r, and this point lies on the tangent, right? So we can use the distance of a point from the line formula, which we had learned in the last class. By that we get what? This A is the radius. So A is equal to distance of this point from the line, which is mod c upon root 1 plus n square. Okay. Hmm. There is another term, normal to the circle. So normal to the circle at a point P is nothing but a line which is perpendicular to the tangent at that point and also passing through the center of the circle, right? This is a general equation of a normal, and this we can get easily by using the form like straight line formula, right? It's just what y minus y1 upon x minus x1 is nothing but y1 plus sorry, upon x1 plus g. This is the slope of the line, right? This thing. This is the slope of the line. So yeah, this was equation of normal. You should remember this. It's important. Tangent from a point to the circle. So this is again important. I don't think I can cover it in 5 minutes. Let's skip this for now. But yeah, I can give you a basic idea. So this is a point which is not lying on the circle, okay? So we all know that we can make two tangents to the circle from this point. S is the equation of the circle. S1 is the equation when we put x1, y1 in the circle's equation. Okay. Now this S1 won't be zero. You will say that x1, y1 satisfy circle. How does it satisfy? It doesn't satisfy, right? It doesn't lie on the circle. X1, y1, when you will put on this equation, you will get a non-zero value because it doesn't lie on the circle. When you multiply these two equations, you will get t squared. And you know what t is, right? We define t as this thing. We define t as this, right? So this t square is nothing but s into s1. When you solve for x and y, you will get the equations of the tangents for this. So this is a good method for this. You should remember this. Whenever two tangents are asked, or what they will do, they can give the equation of these two tangents, and they can give the point. You can now find ss1 equal to t square and compare whatever you get with the equation of the tangent given. You would be asked to get some parameters based on this. Okay, let's move forward. Length of a tangent from a point to the circle. So this point, we are throwing two tangents. We are asked the length of tangent. So we all know these two tangents will be equal in length. So if you find the length of one tangent, it's fine for us. And so what we can do is we can apply Pythagoras theorem in this triangle. Okay, Pythagoras theorem in this PVC, triangle PVC. So PV square plus BC square is nothing but PC square. When you apply the formula, and what you will get is root S1. So length of the tangent from a point P to the circle is nothing but root S1. What is root S1? This equation root S1 you have, right? See, what is S1? When you put x1, y1 in the equation of the circle, whatever you get is nothing but S1. And when you take root of that S1, that is the length of the circle, length of the tangent from the point P to the circle. Okay, so this is the shortcut of finding the length of the tangent. So chord of contact, when you throw two tangents from a point to the circle, these two points when joined by a line, this line is called the chord of contact. Chord of contact, C of C. Okay, chord of contact. Okay, you don't need to remember this. Yeah, so I guess we are at the end of this session. Let's continue next time. Okay, thank you so much.